Support for Built to Last is provided by
Unico Incorporated, manufacturers of the small duct high-velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Bosch, power tools for professionals. Proud sponsor of The Green Home. Florida Tile. Expect more. SPI Incorporated, protective coatings, proven performance, and real-world solutions for 24 years. Additional funding is provided by these firms.
We're almost done with our Built to Last Green Home project, and we thought it would be a good idea to review some of the key building steps we've taken to make our home efficient and also comfortable. So let's take a look at some of the work that's been done on our home. The first part of the process began long before we broke ground. Our planning team met to define our objectives and make sure that all contributors to the home were working together to meet our goals for sustainability. Once our location and plans were set, it was time to prepare for construction. Our surveying team came to mark the lot lines and parameters of the home. After that, our silt fence was installed to meet local code requirements and reduce the possibility of soil erosion during construction. After all the preparation, we were ready to excavate and prepare for the foundation. All successful projects start with a good foundation, and so did our green home. We started our foundation by pouring the footings. Rebar was set inside the footing forms to give them extra strength to support the foundation walls, which incorporated a green technology called insulated concrete forms, also known as ICFs.
The insulated concrete forms are two sides of insulated styrofoam. On every 8 inches there's a nailer that actually holds from front to back on a styrofoam form that actually makes up the insulated concrete form itself. On the blocks themselves, the ICF insulated concrete forms, they're not only between the black tabs, which are the nailers, but there's 1-inch increments in between that also. That you have to actually cut on the 1-inch increments to keep your black lines all in a row. Once the project is complete, you'll see that all of the black lines are in a row, and that helps for keeping everything straight for drywalling, for nailing. Plus, when you're cutting on your 1-inch increments, if you stay on those, it will always keep everything in line. The insulated concrete forms, we build the first course, we put the second course on that locks our wall together. On top of the footing that our form will sit on, we actually take a adhesive foam that actually holds the block to the footing, which then also holds the block in place. We need that to stay in that on our red lines that are already snapped.
Once the ICFs were set in place, it was time to fill them with concrete. Here, we used another green product, since the mixture for the concrete was made with fly ash, a byproduct of energy production that would have otherwise ended up in a landfill. The pouring of the basement floor was the last step in the foundation process. Here, we took more steps to ensure that the basement area's living space would be comfortable and efficient. The first step in completing the basement floor was to install a vapor barrier and then rigid insulation to keep moisture out and heat in.
The rigid insulation here, it's part of the LEED criteria. It kind of gives us the thermal barrier for the whole basement slab, and it's part of the whole envelope system of the house. By doing the 2-inch rigid insulation, we get an R10 value for the floor slab.
A good analogy for the insulation that we're putting in today is kind of like the soles of your shoes. So when you go out on a really cold day and you're walking around in your stocking feet because you're too lazy to put your slippers on to get the newspaper, you know, that cold just transfers right to that sock. However, when you put your shoes on, you've got that good separation. So that's what our insulation is. It's like the sole of your shoe.
We also installed a radiant heating system on the lower level, which utilized 2,000 feet of tubing to deliver heated water throughout the basement floor. After our radiant heating system was tested, it was time to pour the basement floor. And with the foundation cured, it was time to start building up.
The framing that we're doing for this house is advanced framing for carpentry. What we're doing is we're taking advantage of the properties of the wood, using them to their limits, which allows us to space the lumber 24 inches on center. Basically, we cut out about 1/3 of the lumber. There's a cost savings there. We size the headers for the openings in lieu of just doing 2x12 headers everywhere for doors and windows. We're able to go down to 2x6s for smaller window and door openings, so we're not using excess of wood. So we're trying to minimize the wood that's being wasted and used on site here.
Once all the walls were framed, a specialized sheathing system was installed. The walls were then tipped up and the supports and floor joists for the main floor were installed. The framing for the next levels, as well as the trusses for the roof, were constructed using the same advanced framing techniques, which helped us use about 1/3 less materials than conventional framing. It was then time to install the exterior surfaces of our home. In addition to the sheathing, a layer of rigid insulation and a water barrier were blanketed around the home to provide additional protection. Our carpenters then installed 33 windows and 4 skylights to make use of natural light, and fiber cement trim was used for the fascia and soffits. Then it was time to lay down our roof.
The shingles on this project are Energy Star rated shingles. The neat part about this product is threefold. Number one is that it has a reflectivity that is measured by the government for the Energy Star rating, which is at least a 0.25 SR value. Now that translates into a solar reflective index of 29% of the UV light is actually reflected off of this roof so that it's not absorbed into the shingle, which then would absorb heat into the roof. And what it is basically a white coated granule on the underneath, or the first base coat of the granule is white. And the pigment or colorant that goes over the top of that granule basically allows UV light in, but then it's reflected out because of the white. And that gives it the characteristic of the Energy Star rating and the solar reflective value.
After our roof was protected with solar reflective shingles, it was time for the masons to get started installing brick and stone around the home.
Next step is masonry. So we're getting set, and you can see our brick's been delivered. We got our stone on site, so we should be ready to go shortly. Our stone and brick are from local distributor in the area. Our mason, he's got many years experience, an old-time mason, so he's a hands-on guy, so we're very excited to have him on board. We have some challenges here. We're using a jumbo-sized brick, trying to incorporate the brick with the stonework and some of the other things we got in place. It's going to be a little bit of a challenge, but he assures us he can work everything out.
Currently on this project, we have 4.5 guys. A project like this takes 2 to 3 weeks, depending on the weather. If the ground gets wet, the laborers can't move the material. If the bricks get wet, we can't lay them on the wall because they'll squish. So dry, dry, dry. That's the key. For the labor to make the mortar, it is kind of an art and a science. Depending on the humidity of the day, they have to add a little bit or a little bit less water. It depends on the brick that you're laying. If it's a real dense brick, it's not going to absorb the water at a higher rate. Therefore, you're going to need a little bit more stiff mortar. If you have a brick that dries instantly, if it's very porous, then the labor is going to need to make the mortar a little more soft or runnier. That way, as you lay the bricks, it can absorb into the brick and it doesn't dry or cure too fast. The key is to maintain your airspace behind the wall. You don't want any excessive water to fall behind the wall, to trap water. You want to get airflow and water flow. That's why you notice the bottom of the wall, we also have what's called a weep vent, which allows any drainage to come down the wall and weep out those holes. Underneath the brickwork, there's a composite, like a rubber flashing. On this particular building, we used a sticky flashing. It's a membrane that sticks right down to the concrete so water can't seep underneath it. Everything rolls out, and any ice damming, that's all eliminated by proper ventilation of the wall. You'll notice in the front of the house, we have the porch area. We left a couple bricks out. Those are called scuppers. That allows water to drain out of the front porch area. You'll notice the concrete on the porch, the concrete guy pitched the concrete down on an angle so any water, ice, snow can kind of flow right out. Because why? Water's our enemy.
Now, with the exterior complete, it was time to move indoors. Our plumbing lines were run. Our electrical wiring and conduit was installed. And our gas lines were roughed in. We also installed the high-velocity air conditioning system, the radiant heating system for the main floor and loft, and the fire protection sprinkler system. After all our systems were put in place and tested, it was time to seal up the interior envelope of our home.
Even a really well-built house is going to have gaps and cracks and areas that air leakage is going to come, and you're going to lose your conditioned air. So the air that you're paying to heat, the air that you're paying to cool, you're going to lose that to the outside. Properly air sealing the building, there's a lot of different ways to look at that. So one of the main areas are the various gaps and cracks throughout the building and sealing those up properly with a product that's going to allow it to expand and contract as that house settles.
You know, even though you might have a great insulation job, if you still have a lot of air infiltration coming into where the insulation is, it kind of defeats the purpose. Because insulation is kind of like a large filter. In fact, a lot of filters are made from insulation. So really that's not going to stop air from getting into the house.
The system that we're using today is actually a two-part foam material. However, it's very safe, Green Guard certified for indoor air quality. One of the great things about that system is we're able to apply that directly to a crack or a gap or an opening where you're going to seal up for air leakage, but yet the product remains pliable, and you'll see it stays soft. It's able to maintain its integrity as an air holdout. Building science studies have shown that up to 40% of your air leakage goes to the top of the house. By using a product that can gasket to the top plate, when drywall gets applied to that top plate, it'll squash that gasket down and seal that area off.
That product that we used cuts down on those air infiltration points and seals the house so it's a tighter, more livable space.
We had done an air sealing of all the open joints and cracks and seals, any place where we might get any air infiltration from the exterior. So once that was all done and set in place, then we're able to come back and start installing our insulation into the wall cavities. So the product we're using is a formaldehyde-free batt insulation. We don't want to have anything that's going to create any type of off gases or anything else.
Started off with prepping the eave vents with the proper vents, which are the styrofoam chutes that are at the eaves, because you want to have good airflow up into your attic spaces. If you don't, you can have possibilities of mold and mildew growing up in the attic. Then we can kind of come in and start putting in the fiberglass batt insulation, which was called out for on this particular project. And in this case, we put in an R19 fiberglass batt because we had 2x6 wall construction for the majority of the house. This house is going to be very tight, but all houses are now becoming mandated by the federal government by the 2012 energy codes, which is a good thing to do, truthfully, because it helps us consume less fossil fuels. In addition to that, makes the house comfortable. The biggest thing about insulation is you really only have one opportunity to do it right. And if it's not done properly the first time, it can cost you for the lifetime of the building.
After the insulation was in place, we hung drywall throughout the home, which helped to define the home's interior spaces.
Our drywall is delivered on site. We're pretty much done with the insulation, so we're getting ready to rock our house.
Wallboard is typically used to be able to cover up the framing that has all the mechanical and the electrical components in it. And it gives you a smooth flat surface to be able to finish all of your walls in your house.
A lot of the aspects we looked at in selecting the drywall was recycled content and lead points for green products. Our is manufactured within a 500-mile radius, so we conform to a local product being locally produced and shipped to the area. So those are savings there. They're great benefits to take advantage of.
In this house, we are featuring a 5/8" thickness panel, which is different than a typical house where you would use 1/2 inch. The beauty of the 5/8" is it is lightweight, and we're using it because of the advanced framing members that are here in this house.
Basically, we're 24 on centers here. So 1/2 inch tends to bend a little bit, you know, when you're installing it. Where 5/8, you get that more stability and more durability on the 5/8, especially on the drywall lids and on your exterior walls.
With our type of ceiling here, we've got a vaulted and gable roofs coming together. There's a lot of intricate corners and things like that that the drywalls are going to have to deal with. A lot of taping and beading issues. And also with the scaffolding going up 2 stories to get to the vaulted areas is going to be a lot of work.
This product, it is 30% lighter than the traditional wallboard. It means that we've taken 30 pounds per sheet of weight out of it on a typical 4x12 sheet. So we do consider it a green or a sustainable product. This product is manufactured using less raw materials. We use about 16% less water in manufacturing this product. And lastly, we can get over 33% more boards shipping to a job site or a customer, which means that there's less trucks on the road as well as less diesel fuel being consumed.
In the basement of our home, we're using a mold-resistant drywall. This normally is in a house that most of them are undergrade or moisture issues could be a problem. For us, we're using it more of a benefit because the exterior and front side and back side of materials are recycled content, paper. So those are things that we're trying to keep our theme of being a green home incorporated into the home design and products.
People take for granted sometimes when they come in and they see the finished result, but really never see what it does take, you know, to build a beautiful home like this one.
After the drywall was set, our team installed the drywall bead, which was made from recycled PVC. Then we mudded, taped, and sanded the seams and joints around the house to make it ready for interior finishing.
The idea of the primer is to seal the walls, give the top coat an adhesive property, and also to create a surface so that the finish coat is not absorbed into the wall to give you a nice even finish. The low VOC and zero VOC products are now becoming the industry standard. All these technologies exist now and have really advanced us to where we are today with the zero VOC technologies. New resins have been developed, new technologies have been developed in order to enhance the air quality. You no longer have to worry about the solvents that were coming out of paints of the past, where you have the new technologies that have been virtually eliminated from those products.
People would think, well, we're not using oil-based paint, so it's not as durable, and that's completely false. They've developed different systems to make the paints more durable, even though they are a latex paint and zero VOC, to give you the same finish, to give you the same lasting time with the paints on the walls and on the trim and on the doors. We're at a process now where our base is complete and our doors that are getting painted are complete and our frames are complete. We'll run tape on the top of the base in the rooms, and we'll cut all the rooms in, ceilings and walls, and we'll patch them, spot prime anything that we've patched out and looks bad, and then we'll go in and we'll finish paint the rooms.
Since our home has a lot of natural light and very open, airy spaces, we're able to go with a little more with colors, not necessarily dark colors, but a little more rich colors in the home. We've selected some medium tone colors in the open spaces and actually went with a little bit darker wood floor because of how light and bright the home will be. Since we have the natural light coming in and the overhangs, the home won't be in shadow too much of the time, and it'll be very vibrant and light.
Typically all the finishes are hand cut in at the ceiling lines and around the base and the doors, and then hand rolled, and it gives you a nice finish on that. The first thing you look at, if there's colors, you look at the ceiling line to see, did they cut a straight line at the ceiling? How does that line look? And that kind of gives you an idea of how good or bad your painter is. Can he cut a straight line at the ceiling? Because it's not an easy thing to do. And typically that's what we make sure. We have to make sure that they're giving quality work, and that's where you'll see it. You'll see it in the cut lines, you'll see it in the patching, and you'll see it in the rolling. Any construction, new or redo, we're kind of the electrician and the carpenter's best friend, because if they come through and they have to move an outlet or they make a hole or typically put a nick in a wall, we'll go through before we finish it and we'll patch it out, spot prime it. And if a miter on a door jamb is wide or looks bad, we can go in and we can fill it to make it look good. So yeah, we're the guys that kind of come in and finish the product off, and typically we're not 100% perfect at anything we do, but nobody is. So you're always going to have odds and ends. So it's kind of up to us to come through and make sure that the quality's there and we can give them a nice finished product. But yeah, we're always the last guys out, so we kind of get the brunt of making, or the responsibility of making sure everything looks good.
The last installation we'll be reviewing is the hardwood flooring. This product not only looks great, but contributes to our green goals.
We've been asked to be a part of this project going over radiant heat, and we needed to come up with a system to put over this radiant heat floor system. And the best system was to do a floating floor. We're using strand bamboo, which is a green product, and it's perfect for this application.
This is a rapidly renewable resource. The growing cycle for bamboo is typically 6 years. That's when bamboo reaches its maturity.
What's special about this particular product is it's made from older growth bamboo. It's actually a minimum of 6 years of growth, which should contribute to a better hardness and a longer durability for the product. It's pre-finished, which any type of VOCs that would have normally been on the product have already off-gassed, and it goes down very easily. It also has what's called the Green Guard certification, which assures us that any emissions that could potentially happen during the install or while it's in the home are below a certain threshold that shouldn't be a threat to our indoor environmental air quality.
Yeah, basically, obviously, we have to clean the floor, make sure that all the dust, particles, and any debris is completely off the floor. Then we lay down an 1/8-inch cork subfloor mat. It helps with the sound and the heat. And then after that, the bamboo gets it's a wood lock system. There's no glue, there's no nails, and it's just like a puzzle piece, it goes together.
We have a railing system in our loft area and we can't anchor the floor solid because we have to keep the movement for the radiant floor. So what we do is we have to do a transition strip that allows a fixed surface and then the movement in the floating surface. So we don't have too many locations like that, but at any point where we've got a fixed stair or railing transition, things like that, we have to accommodate going from a fixed surface to a floating surface.
This is as you see right now, it's been about a 2 to 3 day process. We probably got another one more day to finish. So it's about, let's say, a total about a week.
The homeowners are going to be happy. It's going to be a nice warm floor throughout the whole space during the winter. Comfort, energy efficiency, and I think they're really going to enjoy this.
You can see there are a lot of elements that contribute to constructing a healthy, sustainable, and durable home. It also takes the hard work of many talented carpenters, contractors, and planners to put all these elements together to create a building that's green and built to last. Now that we've recapped what we've done throughout the season, join us next time as we wrap up our project right here on Built to Last, the Green Home.
Visit the Built to Last website to learn about these topics and more. Support for Built to Last is provided by
Unico Incorporated, manufacturers of the small duct high velocity HVAC Unico system. Unico is dedicated to the environment and has been serving residential and commercial customers around the corner and around the globe for more than 25 years.
Great Northern Lumber, providing green construction materials from skyscrapers to residential remodel. Proud to serve you for the last 27 years and into the future in the lumber industry.
Bosch, power tools for professionals. Proud sponsor of The Green Home. Florida Tile. Expect more. SPI Incorporated, protective coatings, proven performance, and real-world solutions for 24 years. Additional funding is provided by these firms.